Okay, this is lesson 5.1 of stretching and shrinking. We're in the final set of stretching and shrinking. During this one, we're going to learn something called the shadow method. We're going to learn how to measure something that is too tall to measure. So we're going to use the shadow method to solve problems. This is where it starts getting pretty fun in stretching and shrinking because you can go outside and try this with just about anything that is taller than you. So, starting out, let's learn how the shadow method works. We're going to find the height of the clock tower using the shadow method. So, on the left here, we have the shadow method layout. We have the clock tower, we have its shadow, and then we have something small like a stick and its shadow. Okay, out of all these three or four things, we have the height, shadow. There is one thing that is too tall to measure, and that is the height of the clock tower. So the height of the clock tower becomes an h. We can measure the other three things. Now, the reason this works is the sun's rays make these into similar triangles. So if we ignore the special pictures and the pretty pictures, and we just look at the triangles, this turns into a problem no different than in lesson 4.3 where we found the missing parts of shapes. And it actually is a lot easier because the triangles are really easy to set up into proportions. Now, we're going to use cross multiply and divide to solve for the height of the clock tower. So we need to set up our fractions. And a good rule of thumb is to put the height over the ground, which makes sense to me. So basically, we're going to make that into a fraction and that into a fraction. So I have h over 30 equals 8 over 5. Cross multiply. 30 times 8 equals 240. Divide by 5. 240. Divide by 5. 5 goes into 24 4 times, which is 20. 4 remainder, bring down the 0. 5 goes into 40 8 times, which is 40. No remainder. The height of the clock tower is 48 feet. Okay. Once you can tell that the picture looks no different than a finding missing parts, then it's no different than a regular thing. Now, when it starts getting a little tricky is when you have to draw the picture yourself. You have to be able to pull out the important information to be able to solve it. So in this case, I pulled it out for you. So B says to draw a picture and then solve for the height of the flagpole using the information below. You are 5 feet tall and you have a 6-foot shadow. Stick figures are good enough for me. 5 foot tall, 6-foot shadow. There's our triangle. The flagpole is h tall, and it has a 30-foot shadow. We have our two triangles. Make fractions. I have h over 30 equals 5 over 6. Multiply. 30 times 5 equals 150. Divide by 6. 150. Divide by 6. 6 goes into 15 twice, which is 12. 15 minus 12 is 3. Bring down to 0 is 30. 6 goes into 30 5 times, which is 30. No remainder. The height of the flagpole equals 25 feet tall. Okay, hard part is drawing the picture. The rest of the part is easy. Setting up your fractions is easy when you remember to use the height over the ground method. Alright, let's try this 2 more times. In this one, you have to pull out the information yourself. So you're going to draw a picture and then solve for the height of the objects in problems 1 and 2 given the information. The Washington Monument is the tallest building in Washington, D.C. The monument has a 500-foot shadow. A 40-foot tall flagpole nearby has a 30-foot long shadow. Use the shadow method to find out how tall the Washington Monument is. So, we have the big triangle that we don't know how tall it is, has a 500-foot shadow. We have a 40-foot tall flagpole that has a 36-foot shadow. make our fractions. H over 500 equals 40 over 36. Cross multiply. 500 times 40 equals, let's see, 5 times 4 is 20. Add in 1, 2, 3 zeros. 20,000. 20,000 divided by 36. I'm going to go ahead and use a calculator for this so I can speed it up a little bit. 20, 1, 2, 3, divide by 36 equals, height of the Washington Monument is 555.55 feet. Circle that and call it good. One way to check your work, just to make sure if it makes sense, the flagpole is taller than its shadow. Therefore, the monument should be taller than its shadow. 555 feet might sound like a lot, but its shadow is 500 feet. Taller than that, 555 is taller than 500, so it checks out. Alright, last one. John uses the shadow method to find the height of his house. He finds that a 5-foot stick has a 4-foot shadow, should say foot, not food. His house has a 20-foot shadow. Big triangle, height of the house, 20-foot shadow, 5-foot stick, 4-foot shadow, height over ground, h over 20, 5 over 4, cross multiply, 20 times 5 is 100, divide by 4, 100 divided by 4 equals 25. John's house is 25 feet tall. Does it make sense? Well, the stick is taller than its shadow. The house is taller than its shadow, 20 and 25. That checks out. Let's go ahead and go back to the worksheet, make sure we answered it entirely. So, lesson 5.1, we're learning about something called the shadow method that is used to measure things that are too tall to measure. We use the shadow method to solve problems. We learned about the shadow method here, learned the trick about putting the height over the ground so that we can solve. We drew our own pictures, drew our own picture again, solved it, drew our own picture again, solved it. What's cool about this shadow method is you can actually apply this right outside, right now, and measure the height of your own house. Okay, sure, that will get you bonus points with the teacher if you measure the height of your own house. Next up is problem 5.2 in stretching and shrinking.